Good morning everybody and welcome to the webinar Automation using Dynamo Integration within the AEC Collection. So for those of you that don't know what Dynamo is, hopefully this webinar will at least give you an understanding of how you can leverage Dynamo for automation within your AEC Collection. Of course, the AEC Collection is quite a wide-ranging license, and it will be interesting to see how we adopt Dynamo within the future. If any of you have any questions, please let us know via the chat functionality on the webinar. We will respond to any questions that you might have. On the agenda this morning, and just by way of introduction, what Dynamo is and why we use it, how we can use it within Revit. I think for Revit itself, that's really where Dynamo came into prominence, because Revit lends itself a lot to this automation. But it has also now been included within Civil 3D for well over a year, and now most recently also in Robot, which is a structural analysis finite element package, and it will probably be included in some more software within the AEC Collection. You will just have to see as time goes on how much that would be worth to you, and then we'll conclude just with a summary on everything that we have talked about. So just want to see if we are getting audio on here. So we just want to see if we're getting audio on here. It seems that nothing is coming through. Okay, it would seem that some audio is coming through. We'll just continue with the there we go. All right, so we've got audio coming through. My apologies for that. So let's carry on with the webinar. First of all, the AEC Collection. What is it that we are looking at? We are considering a license where it's cheaper to buy the AEC Collection for a user if they use typically more than one major product. So if they were using Revit and AutoCAD, then it would be more expensive to buy these packages independent to the AEC Collection. You can find some great help on the AEC Collection online, and specifically with regards to the products that are available within the AEC Collection, we are of course looking at Revit and Civil 3D, AutoCAD and Civil 3D. You can automate AutoCAD with Dynamo as well if you have Civil 3D. And then further on we've got our robot structural analysis that we will be looking at. And then some of the other packages over here in time, perhaps Format, I think you can also have a bit of Dynamo in there, if I remember correctly, Advanced Steel possibly, but Revit is the big one. All right, so that is basically what the AEC Collection is. When you buy one of these licenses, you get all of the software for one user for that license, and if you then have your Dynamo operating on them, then of course you can do some great things, some great automation with that package. But like we said, we're just going to focus mostly on Revit, also a bit on Civil 3D and Robot. Alright, so having a look at Robot, Revit rather, the automation happens by using quite a friendly user interface. So if you are familiar with programming, it will, it'd be like a duck taking to water. It's very easy, and the idea is just to understand exactly how everything fits together. We're not going to go into detail on some of these scripts. I've got quite a lot of scripts that I can demonstrate to you, but they do take time to explain, and in the hour that we've got, I don't think we'll be able to do too much on that front. Just mostly an introduction of what you can do with that script. All right, so Dynamo is installed by default in Revit. You'll find it under the Manage tab towards the right under the Visual Programming panel. You'll see Dynamo and Dynamo Player. To the left of that, you'll see your macros. All right, so macros are other scripts that you can run, but this is Dynamo. And then you also have something called Dynamo Player. So Dynamo Player is quite interesting. What Dynamo Player does is, if you have a design team or a production line of people that are using Dynamo, then, or Dynamo scripts that have been programmed for them, you can run those scripts to perform some automated tasks for your design team. Which they can then load from the library in which you've placed it. Right? So, and then all that's necessary to do is to just play the script that you've created. So adding levels above, that's quite a good example. Over here you can see you can edit the inputs and you can edit also in Dynamo, or you can just play. And let's have a look at what inputs they've got there. So you can say how many levels you want to create. You want to select the level and a distance from the selected level, and so on. Alright, so those are the types of inputs that you would create there. That will then create levels for you above the levels that you've got. Let's quickly see how that operates. So there's level 1, and we want to select 5 levels above that. And so if we run that using the Dynamo Player, this is of course how you would like your guys to operate the software. You can say you want to create how many levels. Okay, so if you've got maybe a 10-story building, which level must you create them above? You can select within Revit the level that you want to use as the reference level, and then you can also specify the distance between those levels. So there we've selected the level. It recognizes it as element 694. That is simply the identity number of that level within this project, the short identity number, not the global unique identity. And then what distance do we want between them? We'll say 4 meters to make it similar to the levels between 0 and 1. And then we play. That now runs, and we'll see that it's created 10 extra levels above our levels. They also report the identity of that level. So if you take something like 309.860 and you want to identify, just to elucidate or explain to you what that identity is, that is then you can select by ID that element, and there we can see that is level 7. Alright, so that's the idea behind Dynamo Player. It's a no fuss, easy to understand, hopefully foolproof way if the script has been debugged correctly. A foolproof way for your team to use your scripts that you've written or your graphs that you've created for Revit. And that's really as simple as it should be. The reality is often quite different, and you might need a specialist on site to help you with that. Alright, so let's have a look at the script quickly. If you look at the Dynamo Player, you can also edit the script. So add levels above selected level is the one that we've used. There's the edit button that will open up the automation graph. They call Dynamo constructions graphs, not scripts. And one should be correct with one's nomenclature. And these graphs are very useful to understand, to look at an example. So this is an easy example to understand. They've added a bit of text, some instruction. You can see this was already authored in 2017. There you can see you can select the level, the distance, and the number. These have been given as inputs. You can see this is an input, and when you do that, it becomes an input to the script that you offer the team that you are working with. So in this sequence, it's basically generating a sequence 1, 2, 3, 4, 5. Okay, so it starts and step an amount 5. Then it creates a level, and then it outputs new levels. So we're not going to run this again, but that would have executed within the environment of Revit itself. And when you make that available, you can just play that script. So anybody on the team, if they want to create levels like that, they can do that. So this is a very simple example, but it illustrates beautifully, or it illustrates in a way that you can understand how you can use these scripts. So we're in the editing environment now, as you can see, and within this editing environment, it's very friendly. So if you wanted to create your own graph, they call these graphs, you can create a new graph, and then you could do things like select elements. That's a typical thing that we start with. We want to select some elements, and you'll see there are many different ways by which you can select elements. You can say select all elements of type, of category. Okay, so if you have built-in categories, you might recognize the Revit categories. Everything in Revit is a family and it's categorized. We should find levels in here. And currently this is running automatically. So there's the level category, and if you then say select all elements of category, then it will select all 12 levels for you. And how you then operate on these elements, that's something for the future. So typically we would like to use any one of these methods to go and select elements. You can also, like we selected the level, you can also select the model elements from within the Revit environment itself. So you can make it interactive, where you then go and click on elements to operate on them. There's a lot that's going on here. So that's just with regards to the element selection. But you'll see that there's a lot more that goes on here. There's the dictionary. And so we often use the dictionaries to map values from one to another. That I found them very useful in the past. There's the colors that you can add if you're into the visuals and the graphics. You can see there's a lot of that going on. You can watch results in little windows. You can get geometry or create geometry from a lot of things. So a bounding box, for instance, if you want to know what the bounding box or what the extents of an element is, how big is a box that encapsulates it, you can see what a bounding box would be. Coordinate systems and coordinate system transforms, it's quite often used if you want to transform coordinate systems. Edges, faces. So I've used this before when just slapping on separate walls as a wall finish. If I have a room or a space element, then I would ask the space element what walls define it, identify those walls, and then generate a wall right next to that wall. So I can apply finish. You can get into materials. There's an enormous amount of automation that can be done. The one thing about automation is you have to figure out if it's going to be worth your money to pay somebody a bit of time to create something for you that might save you more time on the production line. That's really the consideration with regards to cost. But it's interesting as well. You can import from Excel, you can export to Excel. I've done a lot of this as well. It works very easily with Excel. So you're going to store data within Excel and then populate the elements later from that data storage, or write information back into Excel. You can do that. So it's a nice way to store information that you read using a Dynamo script. It's also a nice way to bring information into Revit using a Excel script. And then later on you'll see you've got some maths functions. There's a lot of mathematics that you can do. Lots of formulas that you can do. Of course they do become cumbersome because each one of these is a little block. Okay, so you can imagine these graphs can get quite big, and some logic and or XOR. There's operators. Each one of those you can string together in a logical way for you to go and manipulate a model, ask a model questions, record information, whatever it is that you want to get out of there. Within Revit itself, you can generate views, you can generate schedules. There's an enormous amount available here. And the latest one that we've got is this generative design, where we optimize multivariable inputs in a graph. So it's a bit like machine learning. We run the computer a few 100,000 times maybe, and then we find the optimal solution based on some criteria that we specify. So this is your toolbox really. This is what you've got just from within the box. Then we've got something called packages, where these are nodes that other people have programmed. And there's some wonderful examples in here as well. So these guys like the parametric monkey guys. That's one that I always remember, simply because their name is so unique. I'm just waiting for the list to populate. Right, you can see there's an enormous amount of extra content that people have created for Dynamo. It's a very vibrant community, a very helpful community in the programming world as well. People are very happy to engage and to so there you'll see Clockwork, for instance. That's one that I've used before. There's the parametric monkey. And if you install something like Parametric Monkey, it's 2018, there's 2022, archlab.net, that's also a good one. Conrad K. Sobon, he's a very good or famous contributor to the community. You'll see that it contains some Python scripts. It gives you a warning. I personally have never picked up a virus from any one of these packages, so I'm quite comfortable downloading and installing these packages. It's not something that concerns me at all, and hopefully you can also enjoy the extra functionality that this affords you. So once you install a package like this, you'll see that you've got your archlab.net. And there we can see, for instance, we've got some Excel commands. We've got some extra stuff that we can use within our Revit. And so within here, people are writing extra nodes that you can use. For instance, you can get a built-in parameter by name. You can change a family type, you can add a shared parameter to a project, and you can set a type parameter and so on and so forth. There you can see what it looks like. So in a situation like this, where you've created a custom node, these are called custom nodes, they're not difficult to create. Really, you've got inputs and outputs. You can edit the custom node. It will open it up in its own little dialog. Tells you that it creates Python, or it contains Python, and that's fine. Okay, now one of the reasons why I like these types of packages where the guys expose their working is that you can edit this Python script. So this becomes important once you move beyond what the packages or Revit allows you to do. You'll see that they've added the proto-geometry reference, the Revit services, the Revit API, and the Revit Nodes. It's a Python way of making sure that I suppose the equivalent to a .NET thinking would be that your namespaces are imported into your drawing. There's different ways in which programmers refer to these kinds of things, but they're importing the references. That's the meaning behind that. So when you type, then it will understand what you are saying. So it's kind of like adding a bit of a language to your script, or adding a subgroup of a language to your script. Then you've got your parameter inputs. Okay, so that's the way that Revit reads inputs. It could be vectors, and then the next part of the script is to define a function. So bits of code that repeat themselves iteratively throughout the program. So one would just say param binding exists, like that, with the inputs being the document, the parameter name, and the parameter type. And then that would run through the rest of this coding there. And then after the definitions, the actual coding starts. The Revit program has a graphical user interface. So a typical user would think that they are drawing a line, or they're drawing a wall, or putting in a window. What's happening in the background is that it's operating against the database. So what you see over here is the transaction manager that's been referenced. And with the transaction manager, what that does is it will either conclude the transaction successfully, or it will roll back the transaction if it doesn't conclude successfully. So it's a bit of database programming in addition to what is happening. And it makes sure that the file doesn't become corrupt. So that's also partly the reason why, when you are working with Cloud Central files, your virtual private networks don't result in a good result as opposed to Autodesk Collaboration Pro. And that's because these transactions, the way that the packages are transmitted over the technology, they're all managed by these transactions. So it's database, it's data based, and then they will try something, and then they'll also give an exception. So this is all programming language. It's Python, all right, and then ultimately it will give you end the transaction if everything concludes successfully, and then there will be an output, either numerical or some other output. It could even, in this case it's text or a message. So if an exception was thrown, then you'll get no shed. Let's suppose that if it couldn't open the shared parameter file, then it will say no shared parameter file found, and it will then output that as the message. So it's a way of catching and throwing and catching exceptions or errors with output messages within Python. So this is a little script that is put together, and then there is the output. So within this node that you see there, this add shared parameter to project, these are the inputs. The person that programmed this node is operating on those inputs against the Revit API, and is doing so via Python. So that's going beyond just the ability to put some nodes onto the screen and to hook them up. So if you're not comfortable with programming, then you can always use the nodes. You can see how far you can get, and you'll also it'll be very instructive for you to go and have a look at the packages and what you can do with those packages. Very often these packages save you a lot of time. So if you're in a production environment, maybe you know that you can do something, or you might be able to do something, but it will take a bit of time. And so instead you will use these packages to save you time. They're free, you don't pay for them. And you can definitely use them. For those of you that fancy yourself really good programmers, and you don't want people to see the source code. In this case, the author has been very friendly in this, in that they release the source code. Personally, I learned most of my Python programming for Dynamo through looking at custom nodes that other people have done, and also reading the building coder. That was a bit more difficult because one has to translate from C# or C++ into Python, but the idea stays the same, so it's kind of like reading a different language and trying to say the same thing in a different language. But anyway, that's kind of programmer's lingo, right? So that's the user interface. It's very easy. There's packages that you can download. There's Python. You've seen what the Python is, and there's the Revit API. All right. So the Revit API. There's some things that very few things, or most things you, let's put it this way, most things you can do within Revit, or automate with Dynamo and Python, especially if you use Python. And you'll find most of what happens within a production environment will probably be within the Revit DB namespace. Right? So this is where you see the things that you can operate on. You can see there's a lot that's going on here. This is the component, what we used to call the component model, or the application programming interface. This is the component model of the software. So if you were busy with say levels, there's the level class. Right, this exposes the level class. It gives you some C# examples here, what you can do with levels. There's some visualbasic.net. So what these top two scripts are saying, just in a different language. And sometimes you're lucky and they're included in Python. So Dynamo and Python is not the only languages in which automation is practiced against Revit. So in a situation like this, you'll just have to look at what is written here and interpret that for Python, and then try and apply the same example. Right? So the members of this class, they call that the level class, but the level members will expose the methods. You'll see there's level methods and level properties. The level methods basically means that's something that you can do with the level class. You can ask it questions, or you can execute things with it. And so there's one, for instance. You can create a new instance of a level based on an input elevation. So the level create method will be used to create the new level that we did earlier. And then it will just run a few times, in our case 10 times, with different elevations, and that will generate those levels for you. So those are all the methods that you can execute against levels. And then you've got your properties. So these are properties that you can read mostly. Most of the properties, well, some of the properties are read and write, so you can change the properties. And some of the other properties are just read-only properties, so you can at least extract the information. And there you can see. So each class that you find, each class of element, each class, component class, has its own methods and level property. And whatever is available to you within this API, you can see we're looking at 2022, but this is the application programming interface. Whatever is available to you here is what you can leverage against Revit using Dynamo and Python, if you know how. They were also very good. They've added some code. Okay, so if you want to learn how this works, they've got C# and they've got Python examples. And within here, you can see, for instance, there's a get elements of category. There's an example of a bit of Python code where you can then go and see how that works. So the filtered element collector, I've used that in the past as well. It's very nice to filter into your selection based on some of the properties that you might be using. And there's a few examples over here. Set parameter by name, I've done that a lot. Extracting parameters, setting parameters. And it's nice to just practice your coding by looking at the examples that they've got. And this is where one can learn a bit of coding if you are so inclined. Zero touch nodes. So that's now if you figure that you're very good at what you do and you don't want the other guys to see what you're doing. So instead of you being able to edit the guy's custom node like is happening over here, remember we could enter this custom node and say edit custom node, and that took us into this interface, and that allowed us to go and look at this Python script. Now you can't do the same thing with just a normal block. Right, so if I took any one of these Revit selection, we saw them earlier, the Revit selection, all elements of category, and I say let me go and have a look at the coding behind here. There's no way for you to edit or to look at the coding that is sitting inside of this box. You can just use it. This one you can see, that one you can't. So if you want to program nodes where you can't see what's going on, in other words it's really your intellectual property, then you can go and program that in as a zero touch node. So this is an Autodesk developer's zero touch nodes. How do you do that? So for those of you that haven't used Visual Studio before, it's a Microsoft compiler. It's a great programming interface where you can go and program and then compile the program or turn the code into machine code, so that in theory at least somebody else can't read your programming. And you would buy a license for Visual Studio, and then you will program that if it's for commercial gain, or otherwise if you just want to try it out, there are free trials as well. And there is a good example of how you can then go and create a zero touch nodes where your intellectual property will be hidden from somebody else. I was quite interested in zero touch nodes, but I've never got to that. I like I like Visual Studio a lot, but it also takes time and reason for you to go and create something like that. Okay, so I've taken you from hopefully not understanding anything about Revit and Dynamo to understanding something about Revit and Dynamo. Hopefully you'll understand that a lot of people have created some wonderful packages that you can use. A lot of those packages have nodes that you can inspect. When you inspect those nodes, you'll often find that maybe the programmer is very good, like the Parametric Monkeys or the Archilab or Sobon or one of the many other famous names within the industry. You can sort of trust what they've done, but of course for programmers that's not always the case, and sometimes you can make their code a bit better, so you can adjust it and hopefully also share it. So we like sharing things within the programming community and helping each other grow and develop the software. It's one of the nicest communities you can ever be part of. That's just with regards to the packages. Be careful though, sometimes the packages might not have been programmed with somebody with the same skill as you. There's nothing wrong with that, it's just you might have to fix something that doesn't work exactly like you think it should work. Right? So just because anybody can really publish a package, but just because somebody published a package doesn't mean that they know what they did. So you also want to inspect what's done If it doesn't work, then you want to inspect what's done. But some of us are a little bit we like understanding things from first principles. So, do we trust what the package is giving us? We've got no reason not to trust it, but how do we know what the package is doing? So we open the package, we read the script, and we say, do I understand what the script is doing, at least in principle or in detail? And should I trust what the script is doing, or what the Python script is doing within that node? So that's also your responsibility to try and understand, if you're a programmer, what somebody else wrote, so that you can trust it. Of course, if it's a zero-touch node, you can't do that. You just have to trust it. If it goes wrong, you won't understand why. And the Revit API, that exposes everything that's possible within Revit. With very few exceptions, I've come across something that isn't possible using the API. Something that Revit might do, but it's not possible. But I've only come across one or two such instances. Most things are possible as long as you understand how. So there's quite a long road. If you're going from zero to hero, then there's quite a long road to travel. There's a big mountain to climb. And to start you off, I would recommend that you use the Dynamo Primer. The Dynamo Primer is for beginners, somebody that just starts out. Takes you through what is visual programming and doing your first little script, how to get started. They're quite heavy on geometry over here, so the architects, they like geometry, structural guys as well. I was more into data, but the geometry just operates on the same thing. And they talk about what is computational design. You can have your geometry overview, so what is geometry? How should you think about the geometry as a line or a plane, as a solid, some vectors, some points? So you must have some, I wouldn't say a lot of mathematical ability, but at least some mathematical ability to do the most simple things. It could get quite complex, of course. Some of the buildings that we find today are driven using mathematical algorithms, the shapes, how to import geometry. And it will carry on like that all through explaining to you what the packages are, how to install the package, a case study on a package, how to develop a package. So if you want to write your own package and share it with other people. So that's what I said to you, engaging with the community and looking at what other people have done and just searching for help online and seeing and becoming part of the conversations that will expose quite quickly who knows what they're talking about and who isn't. And you can publish your package, and then they talk about zero node importing and what you can do there. Right, so then they also give you some best practices, graphing strategies. Right, so you might have many graphs, you might have polygraphs, and they don't all fit together except through a graph. Of course, is a collection of nodes and scripts and so forth. So you can run one graph at a time. They don't bolt onto each other. So you can write one and run it. But you can encapsulate within a custom node, have inputs and outputs, and so you can start putting this concept of polygraphs together, but in terms of using a custom node. All right, so this would be like a short intro into Dynamo, and then once you've got the hang of this, the next step, I like to say that Dynamo is a way for you to ask questions of the model, and beyond that you can now go and optimize. So this generative design, that's really the forefront or the cutting edge of where we are at the moment. Now this, I think, does take quite a bit of skill, just because you have to start going into statistics to generate scripts that would generate a lot of examples. it's very heavy on your computer. So both Dynamo and this technology, it relies on RAM. Okay, so if you are very serious about what you are doing and you want to run things like this, you want to have 64, maybe 128 or more gigs of RAM on your computer, depending on what you're doing. You know, your script might run for half an hour instead of 10 minutes, or for 10 days as opposed to 1 day. You know, so you also have to look at your hardware and what happens to your hardware. You have to start watching your hardware and seeing what your RAM is doing. But what you do with generative design is to have multiple inputs and then to generate a range of possibilities, and then to choose the best possibility from amongst them. Okay, so it's I suppose the equivalent way of thinking about it would be, it's a brute force attack on a problem. So if you try and break somebody else's encryption key, you could just take a computer and say, go through, I don't know, every so many possibilities, run it 1,000,000 times and see if you're lucky. All right? But in this case, the same kind of idea, run something 1,000,000 times and take the best compromise from there, so that your design criteria are met to some other degree. All right, so I would say this, once you get into the generative design programming, I would suggest that you get somebody involved that really understands a bit of statistics and probability as well. So to give you an example, one of the questions that's out there is, you've got a program for a building. Let's suppose you've got a operating theatre within a hospital. That operating theatre has to have services around it, a waiting room, a washing up space, so whatever it is, a certain amount of other rooms that support that operating theatre. And if you have a wing of a hospital, and on that hospital wing you might have multiple operating theatres in close proximity to each other, they might start sharing some of the other spaces and services around them, so that you don't have to have, say, one for each operating theatre, but you might get away with 2 for each operating theatre. And if the ultimate question was, let's minimize the floor space for our hospital wing by running a simulation of the different configurations that we might have for, say, argument's sake, 5 operating theatres, then what is the best possible solution that we can come up with for that, just by spacing the elements around each other? So first of all, we have to programmatically say how things are connected to each other. That might include walkways or hallways, waiting rooms, like I said. And then we have to run a brute force attack on it and say, right, now come up with so many possibilities of configurations, and then show me what is the best possible solution that you've come up with by running that computer against that program, and say doing a few thousand, or if it's worth your while, 100,000, I don't know, depends on how long it takes. But to program the rules about how the rooms are connected to each other, their sizes, what the requirements are, what can be next to each other, what can't be next to each other, that takes some serious skill. And after that, then to go and say, all right, let's go and analyze this in a probabilistic way or whatever, that takes more skill. So that's the kind of level where you are looking at not only somebody that's very good at programming, but mathematics, but also maybe a bit of statistics. Okay, so the generative design, it can be easy depending on the question that you ask and to optimize. Autodesk, I know, is doing a lot of work on this, on generative design, and they've built their headquarters, I think it was in San Francisco or in Toronto. It was Project Toronto, where they've built their headquarters there using generative design. It's a very interesting study. But first you need Dynamo, and then you can use generative design to optimize those designs. So that's the big picture. Right? There's a lot of opportunity within this space that you can think of. If you can come up with an algorithm that optimizes hospital wings, the cost of building those hospital wings is astronomical. So if you were to come up with an algorithm that would be better than, say, for argument's sake, the Americans or the English or the Russians or the Chinese or the Japanese or whoever else in the world is programming, then you stand a good chance of making some good money, because you can analyze hospitals, reduce the footprint, and offer the client a big saving on the money that they are going to spend building that hospital. And that's ultimately, I would say, that's one of the ways in which something like this could pay. Right? But there are many other ways as well. It extends itself into so many avenues. Once you start using computers in ways like this, it becomes very powerful. So there's a good opportunity. Then Dynamo and Civil 3D. I see we're running a little bit short on time, but Dynamo and Civil 3D is also there. So this is a bit more established than Robot, at least. And you'll see that you've got within Civil 3D, and I think it's also under Manage, you've also got your Dynamo Player and Dynamo. So in this case, the nodes that expose themselves operate against AutoCAD and Civil 3D. Civil 3D is also a BIM package, or building in information package. It also establishes a database in the background. And it looks much the same, the interface, but you'll see that the packages are different. So on your selection, for instance, you can select your road alignments, your points, corridors, surfaces by name. There's AutoCAD entities as well. You can see it's not as developed as Revit is. There's still a lot that you can do with it, and a lot of geometry as well. And then the last one is Robot. So the Robot one, you have to download off your account. That doesn't come built into Robot yet. So on your account, just wait for that quickly. On your account, before you run it on Robot, you will have to go to your products, and within your products, under your Robot, under your Robot package, you will go to your downloads, right? And under your downloads, you will go to the updates and add-ons. And this is where you will find your Dynamo extension for Robot structural analysis. So once you download and install this, it then becomes available under the add-ins. Right, so you can see it's a bit different from the other Autodesk packages. And again, what this will expose to us is the Dynamo interface. So another good resource that you can look at, here we go, there's the Dynamo for Robot, and you can see that we've got the structural analysis add-on and the loads. So if you want to vary loads and you want to see what the results are, read the results, so you'll run an analysis. the idea behind this is that you will manipulate the loads, run various load scenarios, calculate the analysis automatically, and then see which one would be the best. Okay, so you can get your results as well and your model. And underneath here you'll find those packages. So the structural engineers, this will be the future of automated design, where you are using a computer to do a lot of the sort of calculation and the automating of your design to come up with a good structural analysis. Mostly meant, I suspect, for structural engineers that are engaged in creating interesting design. So I would say, if you're interested in generative design and robot and Dynamo and what's happening within the world, I would recommend you try Autodesk University. And then let's have a look at Dynamo and Robot, for instance. That's quite a nascent one. Right, so over here you can see, for instance, you've got 2022, so that's from this year, where you can read up on what the best in the world, or some of the best in the world, are doing with regards to using Dynamo to create structural models, results feedback loop, package Python script. So these are then the latest that you can learn, at least from the Autodesk side. And I think once you move into this realm, you'll be learning a lot about what's going on, making good contacts with people in the community, and then understanding also how these things are done, seeing some of the results, seeing how they operate that and what they do. Right. And at least give you what most of programming, I would say, is about, is learning how to do something and then doing your own thing. So have a look also at Autodesk University, not only for Robot but also for Civil 3D and for Revit. There are multiple classes that you can attend for free to learn from what other people have done and become involved in the communities. There's a Dynamo community that you can also become part of, and it's a great community to participate in. And hopefully you can also learn how to automate some of the production processes so that you can save your production team some time. There is a beginner's guide also for getting started for Civil 3D. There's some samples that you can have a look at. That's all included within the help files within Civil 3D. It just takes a little bit of searching. You can see there that you can learn how to run these things. There's some samples as well. Tells you how to read the samples. Or if you install Civil 3D, install the developer's kit, and these things will be available to you. And a bit of an example and so on. It's a bit different from Revit, but they've come a long way in Civil 3D in a few years. And then with Robot as well, like I said, there's a lot that you can do. You probably won't be able to do everything or don't have time for it. But that's in essence what we're about. I see we don't have any questions, but if you do have questions, you're most welcome to contact us at Micrographics, and hopefully we can assist you with any queries that you might have. And I also hope that some of you get the opportunity to do some programming and become involved in this effort. It's my belief that there's a lot of opportunity to save money through automation, and automation or structuring of data protocols are important so that one can operate against the data. So it ties in with BIM in other ways that you might not expect. And the creation of order. You know, if you think about, if you're a business owner or if you're part of a team, and you think about how much effort and time it took to adopt a BIM standard, and you might have asked yourself why. Well, this is one of the reasons why. It's because somebody that can program can operate against the structured data and automate something for you that might save you a week of your time, where something took you a week before, it now takes 10 minutes. That might be worth your while. And the fact that one does that doesn't mean that you don't have a job for the next week. It means that you can then get on with other things. Usually time is a big pressure. And just cleaning up, you know, so it's called entropy, which means that if you put order into the universe, then you automatically create more disorder. And that is what creates work ultimately. Because human effort and energy has to be expended to clean up the disorder, and that creates work. So the conception or the impression that automation destroys work is a debatable issue. It depends on how one views human capital, the development of human capital into more profitable avenues. That would be, if I were a business owner, my priority to see how human beings can be empowered to become the best that they can be. And if that means that they learn new skills to fit into the modern idiom within the workplace, using computers, programming, automation, coming up with better designs, more cost-efficient designs, more energy-efficient designs, less material, that would not only be good in the micro for yourself, for your company, but also in the macro for a nation or continent or even the planet, because of the energy that is getting used and the competitive environment within economies. That is how I personally look at automation, but that also depends on how the technology is adopted by whoever is implementing the technology in their company. So hopefully I've given you some things to think about, that you can try your hand at automation, or maybe employ somebody to come and see if automation is going to work for you. It's not a given, it doesn't always work out, but let's hope that you at least have an understanding of what is possible and what the rest of the world is doing. Until next time, enjoy Revit, enjoy Civil 3D, enjoy Robot, and enjoy Dynamo.